So we'll just go for a revision of what has happened in last week, and we'll move for the session of collection framework, that is linked list in detail today. So in last week we have started with the second type of collection framework, and this is what we have done. The hierarchy up till now we have completed with array list, and now we are started with the linked list. So you are much more familiar now with this, how this hierarchy is there, and we are now with the linked list. Now we'll have just revise what is this linked list and how this is being defined. So linked list as a hierarchy, its parent is iterable. It extend this interface is being extended by collection, and then the same interface is being referred by two different interface again, that is list and queue. Now linked list is directly being connected to list because it contains some special character of listing element in it, but in between these two, that is interface and class, there is one more class that is called the abstract. It is abstract, so it has no definition. It is abstract sequential list. This abstract class is just a declaration. There are many more functions present in this abstract class, which are all being inherited by this linked list. Now see, this linked list is somewhat special. It has a feature of list also, it has a feature of queue also. Queue means it knows who is presiding its element, it knows who is the previous of that element. So we will go into detail about the declaration of this class. So this linked list class is extending abstract sequential list, and as this class is abstract, its name itself is abstract, it means it cannot be creating object directly. So we'll be creating object of linked list. Then it implements some special features like list. This is list interface. It implements means it is an interface. So we are using a keyword called the implements. List also, it has a feature of DQ also, and apart from that is clonable and serializable. So serializable is just like threading concept. It is inherited directly into this linked list, and clonable means we have seen in array list also. It is clonable means you can create a clone of a same class object directly by using some function of clonable. That is clone, name of function is clone. We have already gone into detail in array list. So we will move further. Now we have seen in this previous session that while creating object of linked list is just by using a new keyword, but here we have a special feature of linking is that it goes for singly linked list also, it goes for doubly linked list also. So apart from array list, linked list is somewhat special. What special? See, it refers to its head. It knows that if you are talking about singly linked list, what is singly linked list is just a node that contains information, that is the data, and the node contains information of the another node which has been concatenated or been extended after that list. So this is just what we call as just a railway. You see that first compartment is been attached with the second compartment, and who knows the previous one, next one is here we have in this singly linked list that the list 1 contains the information of second list. List 2 do not contain the information of previous list, but it contains the information of another list which is extending. This is called a singly linked list, and it is been upgraded in your linked list. So you can use just like your C and C++ data structure concept of linked list, that is linking singly linked list. This is the same feature you can do in your linked list ready-made framework collection. Now same way when you go for doubly linked list is nothing but it is been extended into 3 different sections, and one section is knowing the information of who is presiding that node or who is presiding that element, and also the node knows, that is the previous section knows who is his parent node. So you will find that there is always 2 sections, one maintaining the information of another node, and same way it is knowing the information of the previous node, who is his previous node or who is the previous element and who is his next element. So that all information is maintained in doubly linked list. As far as these 2 types of linked list is concerned, it is based on the scenario, what is important for you. Singly linked list is important when you don't want more details about the linking, who is previous and who is next. But when you are very much specific about knowing the information of the previous element and you want to know the information of the next element, that situation is doubly linked list is being used. Most probably in industry, these people go for linked list because this is just your data structure. You find this is an algorithm, this is a data structure, and just by using some function, you can achieve this functionality directly into your Java programming. So same feature is being implemented in linked list, and now we'll go into detail. What are the important things we have gone on that day also? There are some of the important things that it contains duplicate elements. So there is not a unique values being added into this linked list. You can add a duplicate element over here. Second important thing is that it class maintains insertion order. So you know exactly where the element is being added. So it has some sequence of adding element in whole list or in a whole object. Same way it is non-synchronized. It is not synchronized. Synchronized means what? It is been added in the very sorted order. Here we don't have the technique of adding element at a sorted order. So each and every element, if it is added, it is been added directly. There is no synchronization. That is alphabetically it is not been added. Just like we have seen that we want to sort, we have to do explicit programming of sorting the elements in array list also. Same way for sorting, we have to go for sorting the elements in this linked list also. So there is no synchronization, that's why it is called as a non-synchronized linked list. Then linked list class is fast because it is shifting needs to occur, because it is always manipulating something background. We'll go into detail the difference between the array list and linked list in the last slide. So where you find that this manipulation is very simple compared to array list. And something special about linked list is that it is used as a list also. It is used as a stack also, and it is used as a queue also. So you have a different functionality in one single class. That is, listing is also possible, stack creation is also possible, and queue is also possible. So previously when we have talked about data structures, we have to create separate functionality, separate logic we have to write for stack also, for queue also, and for list also. So everyone knows stack is what? Whichever the element is added, you add it to the top. It is not added to anywhere. It is added directly at the top position. So that is called a stack. And what is queue? The new element is always added at the end of this linked list. So if listing linked list, you have created a list and you want to add some element, queue means you are adding at the bottom of that list, that you are adding at the last node. And same way in stack, you are adding at the top, that is on the first node of your list. Same way in this basic list, it has a functionality of adding anywhere, any time, any element at any position. So this multi-feature is being provided in your linked list. So this is always a big question asked: linked list, stack, and queue, how it is being used, and what is the special type of class which inherit all these type of features. So it is just nothing but your linked list. So links, stack, and queue, three are always being used here. So here we can create an object of linked list directly, but it is zero without parameter and with parameter. We'll go into detail how to create an object of this class. So on that day we have gone through this some functionalities, and you will find that these are always repeated. So add is there, add all is there. We have seen in this array list also. Add first, this is a new thing been added here. Add last, because it is linked list. So you have to add somewhere in the top position or somewhere in the last position. Then you can clear the array list also. Same like we have seen that it is clonable. This new interface is extended over here. So this object is from that clone interface. So you can create directly object. That is a clone of the list also. So contains is for the purpose of searching. Iterator, you have already seen iterator is iterable class object and functionality, and it is been used for the purpose of what is called as traversing the elements, what all elements are present over there. Same way there is an element, we can add an element, just like add, there is always you can add with the function called element. We will be having an example of this also. Then get function, you can get an element name, element value by providing its index number also. So this is for the purpose of retrieving the value of a specific node of your linked list. Then get first, get last. You can get a value of your first node and last node also. Then you can get an index of any element. You can get an index of any last index. So it is just like that. List iterator is a separate type of iterator being added into your linked list for the purpose of iteration. Then these three functions we'll talk in detail in later part. Today we'll go into detail about this peek. What is this is? Peek first, peek last, pull first, pull last, pop, push, because these are the two functions of stack. and these all are the functions of your queue. So you can add in the queue also. You can add a push pop, that is stack feature can be added with this. This is nothing but a functionality for implementing stack and queue in your programming. So same way you can remove element. You can